This is question number 22 of June 21, paper 1 2. And it says that two particles in a progressive wave are distanced 10 centimeter apart. Two graphs show the variation with time of the displacement d of the particles. Now, what we observe is that at 0 second, when the first particle, say this is x and this is y, when x is at a crest, at the same time the particle y is at a trough. So one thing is obvious, they are anti-phase, 180 degrees out of the phase. And since they are on a single wave, so the phase shift of sources will not be important here because it's a single source. Now the particles on a wave have a phase shift of 180 degrees when, if x is here, y could be at a distance of lambda by 2, or it could be at a distance of 3 lambda by 2, or it could be at a distance of 5 lambda by 2. So you can say that at odd number multiples of lambda by 2, the particles are antiphase. And it could be a transverse wave or it could be a longitudinal wave, because on the graph, we represent oscillations in all the directions like this. They could be horizontal oscillations, they could be vertical oscillations, or they could be oscillations in some other direction. Now the idea is that these two particles can have a distance of lambda by 2, 3 lambda by 2, or 5 lambda by 2. Now what we have to understand is that if it is a longitudinal wave, then what could be x and y? For a longitudinal wave, the antiphase particles are compressions and rarefactions, you can say that. So if x is a compression, then y should have been a rarefaction. This is the first idea, if it's a longitudinal wave. And obviously their distance is 10 centimeter. And if it's a transverse wave, if it's a transverse wave, then if x is at a crest, then y should have been at a trough, and this distance from crest to trough will be 10 centimeter. And the next crest will be at a distance of obviously 20 centimeter. This distance will become 20 centimeter, and this distance will become 10 centimeters. So what they are saying, particles in a longitudinal wave with a compression and the nearest rarefaction, which means that a distance of lambda by 2, half wavelength, are separated by 10 centimeter. It works because if x is a compression, then y will be a rarefaction and their distance is obviously 10 centimeter. Why B is incorrect? Particles in a longitudinal wave have a compression and a rarefaction at they are not at 20 centimeter. They must be at 10 centimeter because the antiphase points are at 10 centimeter. C option is particles in a transverse wave with a peak and the nearest trough separated by 20 centimeter. No, they are separated by 10 centimeter. And in this option, they are asking about two crests separated by 10 centimeter, which is not the case. The crests are separated by 20 centimeter and the crest and trough are separated by 10 centimeters. So A is the correct option.